Welcome to my video lecture. I am Dr. A.VELMURUGAN, Assistant Professor, Department of Mechanical Engineering, Government College of Engineering, Chettikare, Dharmaburi. In this video lecture, we have discussed about the from upcoming semester Thermal Engineering 2, Unit 2 Steam Boilers from Module 1. Before we have discussed about the steam boiler, first of all you should know about introduction about the thermal power plant. From statistical survey from India, how to produce the electricity generation in India, from coal 59%, natural gas 10%, nuclear power plant 2%, natural gas 9%, renewable energy sources 12%, hydroelectricity power generation 17%. The major contribution of electricity generation in India for fossil fuel is 69%. From coal 59% and natural gas 10%, totally we get 69% from fossil fuels. The thermal power plant major contribution of power generation is in India. The schematic view of the thermal power plant, how to produce the electricity with the help of the coal as a fuel. From the coal is entered to the combustion chamber, it is the pulverized fine particles. After the flue gas is entered to the furnace from the boiler tube, the water will be circulated from this place. Automatically the steam is produced from high pressure steam or high quality steam. The dry structure or superheated steam is formed. From the help of this nozzle, the high velocity steam is rotate the turbine plant to produce the power electricity, and the excess steam is entered to the condenser. With the help of the condenser is nothing but that is a heat exchanger. Again that water is sent to with the help of the feed pump goes to the boiler, and repeatedly the cycle will be repeatedly done to produce the electricity. From Unit 2 steam boiler, the major content is types and comparisons, mounting and accessories, fuels, solid, liquid and gas, performance calculation and boiler trial. From boiler is nothing but it is a closed vessel in which to produce the steam with the help of the water by combustion of the fuel. The steam will be generally following from similar categories for generating the power in steam engine or steam turbines, in the textile industries for sizing and bleaching etc., and many of the other industries like sugar mill, mainly chemical industries are used for the boilers. For heating the buildings in cold weather or producing the hot water from hot water supply from the buildings and high buildings, the mainly from India the most number of thermal power plants to produce the 69% fulfill for the electricity generation in India. Particularly from the Tamil Nadu, so many thermal power plants are available. In south in particularly from the Neyveli Lignite Corporation, they produce the high electricity, and also Ennur thermal power plant, North Madras, Mettur power plant. The classification of boilers are horizontal boiler, vertical boiler or inclined boiler, fire tube boiler and water tube boiler, externally fired or internally fired, forced circulation or natural circulation boiler, high pressure boiler and low pressure boiler, stationary and portable boiler, single tube or multi-tube boilers. Based upon the category types of boilers, horizontal and vertical or inclined boilers are if the axis of the boiler is horizontal or vertical inclined, then it is called horizontal boiler or a vertical boiler or inclined boiler respectively. Two types of boilers, fire tube boiler and water tube boiler. If the hot gases inside the tube, water will be circulated from the outside of the tube, it is called fire tube boiler. Examples: Cochrane Boiler, Lancashire Boiler and locomotive boiler. If the water is inside the tube, the hot flue gas is circulated outside the tube, it is called water tube boiler. Examples: Babcock, Wilcox, Stirling, Yarrow boiler, etc. Some categories: externally fired or internally fired from the flue gases. The boiler is known as externally fired if the fire is outside the shell. Example: Babcock and Wilcox Stirling boiler. Another boiler is known as internally fired if the furnace is located inside the boiler shell. Example, Cochrane Boiler, Lancashire Boiler, Baby Boiler, Simple Vertical Boiler or Locomotive Boiler. The water will be circulated from two categories. One is a forced circulation, another one is a natural circulation. In forced circulation type of boiler, the circulation of water is done by a forced pump. Example, Ballack's boiler, Lamont boiler, Benson boiler. In natural circulation type of boiler, the circulation of the water in the boiler takes place due to natural convection currents produced by the application of heat. Example, Lancashire, Babcock or Wilcox boiler. Depending upon the pressure rate, the high pressure steam is formed from the above 80 bar in the high pressure boiler, below 80 bar from the low pressure boiler. From the boiler which produce the steam at high pressure 80 bar and are above are called high pressure boiler. Example, Babcock boiler, Wilcox, Velox, Lamont, Benson boilers. The boilers which produce the steam at pressure below 80 bar are called low pressure boilers. Example, Cochrane boiler, Cornish boiler, Lancashire boiler and locomotive boilers. The boilers are present in stationary type or portable type boilers. From the stationary boilers are used for major power plant to produce the steam for central station and utility of power plants for plant process steam, etc. The mobile boilers or portable boilers. The mobile boiler is nothing but locomotive engine or marine applications. Portable boilers are include locomotive type and other small unit of temporary use at sites. The single tube and multi-tube boilers, the fire tube boilers are depending upon the whether the fire tube is one or more than. The examples of single tube boilers are Cornish or simple vertical boilers. Before we have to discuss about the important terms of the boiler, first of all you should know what are all the essential for to produce the steam boilers. The boiler should be produce the maximum weight of the required quality of minimum expenses. The steam produces rate should be as per the requirements. It should be absolutely reliable. It should be occupy minimum space. It should be in light in weight. The important terms for boilers are the shell, setting, grate, furnace, water space and steam space, mountings, accessories, water level indicator, refractory bricks, foaming of the boiler, scaling of the boiler, blowing of cock, lagging. Before, the shell is nothing but the shell of a boiler consists of one or more plates bent into the cylindrical form and riveted or welded together. The shell ends are closed from the end plates. From the setting is very important from the boiler. The hot flue gases, if we get the better combustion, the setting is very important. The primary function of the setting is to conform heat to the boiler and form a passage of gases. It is made up of refractory bricks made from the furnace wall and a combustion chamber. It provides the support for some type of boilers. The grate is nothing but in the platform of the furnace upon which is fuel is burnt and is made up of cast iron. The bars are so arranged that air may passes on the fuel for combustion. The area of the grate with the fire rest, coal or wood, fired boiler is called grate surface. Furnace is nothing but it is a closed chamber formed by the space above the grate. Below the boiler shell in which the combustion takes place, it is also called fire box. Water space and steam space are nothing but the volume of the shell that is occupied by the water is termed water space, while the entire shell volume less the water and tubes. The space is called steam space. The mountings are very essential to operating the boiler. From the safety point of view and also without mountings we will not operate the boilers. The mountings are nothing but there is a stop valve, safety valve, water level gauges, fusible plug, blow off cock, pressure gauges, water level indicators are termed as a mountings, and a boiler cannot work safely without them. Accessories are nothing but superheater, economizer, feed pump. Accessories are to increase the efficiency of the boiler. Water level indicator is nothing but the level of the water stands in the boiler is called water level. The space above the water level is called steam space. The refractory is nothing but the heat insulation material is surrounded from the refractory bricks, such as a fire brick or plastic liners from the fire clay used for the purpose to lining combustion chambers. Foaming is nothing but the formation of steam bubbles on the surface of the boiler. Water due to high surface tension of the water. The scaling is nothing but we get the before the water is entered to the boiler. From the process of water treatment process, we have to remove the scaling. The scaling is improve the condensation process and also medium to extreme hardness occurring on water heating surface of a boiler location because of undesirable condition of the boiler of the water. The blowing of cork is to remove the mud and unwanted materials. Salt contamination is present on the boiler with the help of the blowing of cork to remove the unwanted particles. Now we have discussed about the various types of fire tip boiler. First we have discussed about the Cochrane boiler. Thus the figure shows simple vertical and also the Cochrane boiler. The Cochrane boiler is mounted for various accessories and mountings, that is a cylindrical shell, combustion chamber, fire brick lining, furnace is from the shape of dome, blow of cork, steam stop valve is present in the upper of the Cochrane boiler, anti-priming pipe, pressure gauges from the safety point of view, fluid tube from the combustion chamber, smoke box from the furnace, chimney from the exhaust of the boiler, fire hole grate from the bottom of the boiler, safety valve, ash pit, manhole, water level gauges. From the Cochrane boiler, the multi-tube layers are present. It is internally furnace will be fired, the tube boilers. It is a portable and very popular boiler. The size of the boiler is 2.7 meter dia and 5.7 meter height of the shell. The steaming capacity is 3500 kg per hour. The working pressure is 20 bar. The various features are present on the Cochrane boiler. It will be very compact, require minimum floor area. Here we have to using any type of fuel can be used, well suited for small capacity requirement. The thermal efficiency is 70% with coal firing, thermal efficiency of 75% with oil firing. The ratio of the grate area to heating surface area varies from 10:1 to 25:1. The various mountings are before we have to operating the boiler means the mountings and accessories very important. The pressure gauges to maintain the pressure level with the help of the board tube pressure gauges. Water level indicator with this made up of glass, and also transparently we have to see about the water level in the boilers. Safety valves are to prevent the pressure, high pressure will be increasing means the boiler will be busted. So that condition we have to using the safety valve to prevent the pressure not to increasing above design pressure, spring controlled control. So for example in the cooker also we have to using the gauges, that is a safety valve. So if you have produced the high steam means if this the whistle will be released, and also the same concept is roll on the boiler also. From fusible plug, when shell temperature will be increases above the particular level, it melts by creating the opening through which pressurized water falls on the grate extinguished by air. The blow of cork when open, the steam pushes water at the bottom, remove slurry, salt, contaminant, dust, etc. The steam stop also regulate the steam supply outside the boiler. The feed check valve, high pressure feed water is supplied to boiler. This valve prevent the backflow of the steam through the valve. Before we have discussed about the Cochrane boiler. Cochrane boiler is consists of cylindrical shell with a dome shaped top with the space provided to steam. The furnace is one piece construction and it's seamless. It is a shape of crown from the hemispherical shape and they provide the maximum volume of spaces. The fuel is burned from the grate and collected to deposit from the ash pit. We get the better combustion to find out the